resistance of a multimeter, forward bias resistance of a diode is much smaller than the resistance of a multimeter. In the market, we have variety of multimeters. You are here in this lab also, you will be using a multimeter costing 100 rupees, at the same time 3000 rupees also. Okay, so I think it depends upon the internal resistance of this. So if you measure if you are using a reverse biased PN junction and measure the voltage across the diode, sometimes you will end up with the wrong IV values. The reason is, if the resistance of your voltmeter is comparable with the resistance of a diode, so what will happen? In fact, if you have a resistance, because normally this is my resistance, I want to measure the voltage across this with a voltmeter. So I have a current I going like this. Okay, this is my R. So we want to measure V to be equal to IR. So what we want is that if the resistance of this voltmeter RV is infinity, then there will not be any current to pass through vertically, and we are going to measure this. But what will happen? This can't be infinity. Okay, this will have some value. If these two are comparable to each other, suppose this is R. So what will happen? Now the current will be divided. This becomes I by 2 and this becomes also I by 2. So in place of IR, you are going to measure IR by 2. So here again, you are using a voltmeter. So voltmeter means this current is very small. I have taken that in fact as 1 microampere. I assume that the resistance of this is much larger because you are using small resistance. So small resistance means we calculated the resistance. It was a milliohm. 194 probably micro. So if it is micro ohm and so resistance is very small, copper wire. Okay. So even if you are going to connect a voltmeter there of mega ohm resistance, the current will be very small. You can apply Kirchhoff law to find out the larger the resistance, the smaller will be the current. So the current across the two contacts will be negligible and you end up with the current. So for this, okay. So here now there are, so this is the arrangement, we can't see it anyway. So we have now two connections for the thermocouple again. One connection is made onto the copper, okay, and another connection on the top copper plate. So we assume as if the heat taken by the copper is negligible. So the differential couple measures the sum of the temperature drop across the perspex plate, because we have one connection at the lower plate copper and outer copper. In between we have basically the perspex plate that is sandwiched between them. So the temperature drop across the copper plate from the surface to the point. So we are using this, but because of larger value of thermal conductivity of copper and much lesser than the value of thermal conductivity of perspex, the contribution of copper is very small, so that has been neglected. Okay, so we assume as if the temperature drop is across the perspex. The copper is a good conductor. Okay, so copper contribution as compared to perspex is very small. Okay, and again we need a constant current source, thermal conductivity box. The beauty of these two experiments in the beginning, okay, you must be feeling that how is it possible to complete 3 experiments in a span of 2.5 hours, 45 minutes waiting for the study state. Professor Srinivasan has designed these experiments like this. You can use the same heater, you can connect the poor conductivity setup and the copper conductivity setup in series with each other. So you are using the same setup. Okay, and the parameters have been designed in such a way so that you have I square R heating in one and similar I square R heating in the second. So in 45 minutes you can perform both the experiment. Both the boxes are there. The thermal conductivity box of copper are connected to L1 and L2 of DC differential amplifier, and this is connected to the third one L3. Finally, when the experiment is over, then you go for electrical conductivity. By electrical conductivity, you have to change the current and find out the corresponding voltage at the two intermediate ends. So in this case, again, we are not supposed to increase the current. So 2 ampere, you have to change, then V2 plus and V2 minus our thermocouple is measured. Okay, these are the readings, and the value comes out to be 0.25. Here again, this is so anyway, in fact, this is the previous slide. Okay, I think it's hanging somewhere. So you are measuring the thermocouple reading. The formula is A into D upon A into Q over delta T. So we have to calculate the value of Q over delta T. Q comes from the heater resistance and the current, that is I square R. Delta T can be obtained by the thermocouple reading. One end of a copper constant thermocouple is connected to the copper base or the cup which encloses the heater, and another is connected to the top copper base. Okay, and we can perform both the experiments simultaneously. So 45 into 5 for 5 readings. Okay, and last few minutes or 3 minutes or maximum 5 minutes for electrical conductivity. So this is the value that we get for thermal conductivity of first capacity. The theoretical value is 0.2, we get 0.25. Okay, the dimension of this is what I was telling you. The dimension of object is also chosen that one can pass the same current through the heater as in the thermal conductivity of copper sector, so that one can connect the same constant source through both the experiments. And you can make use of all the three terminals of a DC differential amplifier, and you can see. Any questions? Yeah, you can use it if you are going for suppose I want to demonstrate to my students some experiment. I will go for two-proof method. The student will design. Okay, but the condition is resistance to be measured must be large. But for semiconductor, all you have a thin film. We go for four-proof method. Four-proof method, the outer tube for current measurements and inner tube for voltage measurements. Yeah, germanium crystal, and we measure we make a four-proof method. Silicon area two-proof, you can use two-proof also for silicon. Silicon resistance is higher. But for thin films, four-proof is good. Okay, so I will learn now. I think that the breakdown heated or heated.